Welcome to Introduction to Geographic Information Systems. This, and the other learning resources in this course have been made possible by funding from the European Commission's Erasmus Plus program. While this learning resource, and the course in general, uses cultural heritage and archaeological examples, they are general enough that anyone can follow along, regardless of your interests and intended applications. This is the first tutorial of this course, and we will focus on the following topics. 1. What is Geographic Information Systems, or as it is commonly called, GIS? 2. What can you use it for and why would you want to use it? So let's get started with what is Geographic Information Systems. First point to get out of the way, almost everyone shortens it to its acronym of GIS. If someone has heard of Geographic Information Systems, they will know what you mean when you say GIS. So what is it? 1. It can be a conceptualized framework for capturing and analyzing geographic data. Basically, GIS is a way of doing things. It is a way of approaching certain problems and managing certain types of data. However, most people when discussing the term are referring to it as a computer program that allows them to work with geographical data. Indeed, when someone says, use GIS, they are rarely referring to a framework and are actually talking about a specific software such as ArcGIS or QGIS. The focus of this course is to develop your skills in the computer software, but the theory behind it is just as important. As will be discussed later, and raised throughout these tutorials, you want to be careful you are not undertaking push-button work, and you understand what it is you are actually doing. So what is GIS, the software? Well, it is not just one program but a whole range of programs, and there is not a single agreed upon definition. There is no organization that certifies a computer program as being a GIS or not. But, in general, the accepted definition at its most basic level is a tool to work with geographic information. In particular, a GIS is a system that should allow its users to undertake the following operations. 1. Data capture and preparation. 2. Data management, including storage and maintenance. 3. Data manipulation and analysis. 4. Data presentation. While that sounds like a lot of different types of software, it is important to remember, the G in GIS stands for geographical, and that the software deals with geographical data, a type of spatial data. Spatial data refers to where things are and can cover so many different applications such as the distance your hands are from your feet. That is spatial data. Geographic data is spatial data pertaining to locations on the Earth's surface or relative to it, like the atmosphere or tectonic plates. So GIS is a specific piece of software with those advanced capabilities that deal with geographic data. What can you do with such a program? Lots. If you are interested in urban planning, you might want to assess the extent of urban fringe growth in your city, and quantify the population growth of some areas. You also like to understand why these particular areas are growing and others are not. GIS can help you do that. Maybe you are interested in archaeology, then you might want to understand the line of sight between defensive structures on a hill fort. GIS can help you do that. If you are interested in biology, you might want to understand how slash and burn agricultural practices impact on the populations of amphibian species in your study area. GIS can help you do that. For those interested in natural disasters, you might like to identify the high-risk areas for flooding by investigating rainfall patterns and terrain characteristics. GIS can help you do that. People interested in construction might want to identify the best localities for constructing buildings in an earthquake-prone area by looking at rock formation characteristics. GIS can help you do that. If you are a forestry manager, you might want to optimize timber production using data on soil and parent tree stand distributions. GIS can help you do that. People who have to manage heritage sites might want to see which of their sites will be affected by rising sea levels. GIS can help you do that. To better illustrate the potential of GIS, let's take that last interest, heritage management, and see a real-world example. A few years ago, heritage managers in the southeastern United States wanted to know how rising sea levels, because of global warming, would affect archaeological sites in that region. So they gathered together a dataset of all the archaeological sites. They also got a dataset of the elevations. They then imported the two into a GIS and combined them to find out the elevation of every site and modeled changing sea levels to see which ones would be submerged under different scenarios. They now know which ones are in most need of protection over the next few decades. This is but one of millions of examples of how you can use GIS tools to help you with your spatial problems. A little background and history of GIS and where it is going. If at its very basic level a GIS is something that allows you to capture and analyzing geographic data, then it might sound like something else you know. A map. Maps are tools for storing data, they are a tool for analyzing data, and they are a tool for presenting data. Maps have been with us for thousands of years, and you can think of them as the precursors to GIS. Like the Imago Mundi, a Babylonian map, and the oldest known world map, or Inuit wooden tactile maps. However, GIS is a step beyond traditional maps in its abilities. A map can only store as much information as that can fit on its physical surface, but GIS can store and use vast amounts of data, terabytes of it. A map is usually fairly static and is usually set in its presentations, while a GIS can create unlimited presentations. You can think of GIS as maps supercharged through the powers of computing. Indeed, that is how GIS was first developed. The term is widely attributed to Roger Tomlinson, who used it in 1963 to describe activities in building a digital natural resource inventory system for Canada. GIS was just a combination of ideas from quantitative cartography and the computer systems that existed at that time. It was basically the work of cartographers and geographers who tried to adapt their knowledge and their needs to a technology that looked promising. Since then, many other disciplines have contributed to the creation of modern GIS. It has evolved to adapt to changing circumstances. Originally, GIS were only on large mainframe computers that only a few organizations in the world had access to. But it moved to personal computers and graphical interfaces in the 1980s. Now they can be found on the internet, and there are cloud GIS services. How we gather the data to input into GIS has changed as well. One used to have to collect elevation points by hand, but this can now be with a drone through LiDAR or photogrammetry. In a few short decades, GIS has evolved significantly and is likely to change further. You may not recognize it in a few years' time. Though as it currently stands in 2020, desktop GIS is still the dominant type of software. There are two leaders in desktop, Esri's ArcGIS and QGIS. Esri was founded in 1969, and its products have played a key role in the popularization of GIS. They are estimated to be a billion-dollar company, and with those resources they have ensured that ArcGIS is at the cutting edge of development. However, the drawback to this is that ArcGIS is a proprietary software that you must pay to use. ArcGIS comes in 3 different license levels: Basic, Standard and Advanced, and can be purchased with additional add-on packages. A single license can range from a few $1,000s to well over $10,000. In addition to software licensing costs, ArcGIS is only available for Windows operating systems. QGIS is the most popular open source option. It has most of the functionality included in ArcGIS. It is a relatively recent GIS system, with version 1 only being put out in 2009. However, much of the open source community has rallied behind it, and it is improving by leaps and bounds every year. Moreover, QGIS can also be used as a graphical user interface to GRAS, an open source GIS, first released in the 1980s by the U.S. Army Corps of Engineers. This allows QGIS to utilize the decades of GRAS development, making it a powerful GIS to use. It also works on Mac or Linux computers. There are advantages and disadvantages to proprietary and open source software. For proprietary software, the obvious disadvantages are the cost. Also, a lack of ability to be able to alter the software to your needs. Finally, many proprietary softwares are moving to software as a service model, where you must pay a monthly fee to access it. If you stop paying, then you lose access. They sometimes use proprietary file formats that can only be read by their software, so you can't take your work to a different program. Basically, there are all sorts of ways proprietary software providers try to lock you into using just their software. The advantages are that they usually come with support and tend to have the most recent developments and a wider range of functionality. They also tend to be focused on usability, as they want to have the highest possible number of customers, so they make it as easy to use as possible. For open source, of course, the main advantage for a lot of people is the price, free. Also freedom. You can change the software as you see fit, and you never have to worry about access being cut off. They are free to try before you buy. If in the future you want to change software, you don't have to worry about losing money. Basically, no vendor lock-in. They work on open standards. Lots of proprietary software will also use proprietary file formats, which means only their software can read and work with the files. Open source software does not do this. These next two advantages are more debatable and really apply to both open source and proprietary software. It is claimed that open source software has fewer bugs and less security issues because more people can look at the code and find problems. However, the opposite can also be true, in that some open source projects only have 1 or 2 people working on them, so this is not always true. The disadvantages of open source is that you usually are on your own when it comes to support. though there are many companies that will provide this, for a price, which somewhat negates the free aspect. Also, development follows the interests of the open source community, which may not align with what you need out of the software. Finally, there can be issues of usability. This is not true of all open source projects, but many can be designed for programmers and not everyday users. This is not an all-inclusive list of all advantages and disadvantages, but gives you an idea of what the main ones are. Also, these are generalizations. Some open source software can be very easy to use, while some proprietary software can be a real pain to use. The same for support. What is constant between the two is the difference of free and freedom. Which should you use? That is dependent on your needs, your circumstances. Maybe you prefer a dedicated support line that you can call to get help. Maybe you don't have hundreds of dollars, pounds, euro, yen, whatever, to spend. Decide on what is best for you based on what individual GIS programs offer. We will be using QGIS for this course because it makes it possible for more of you to learn. Though once you learn the basics, you will find the concepts are the same between different GIS programs, just with different interfaces and maybe some different functionality. Once you feel comfortable with QGIS, you can explore other GIS programs to see which ones fit your needs the best. The next video will show you how to download QGIS so you can get started learning.